All right, last set of examples for this lesson. A very similar process here. What we got to pay attention to is that our answer is going to be different. The way we write our answer is going to be different for these problems. We are being asked, or we are being given zeros of these, and we need to find the other zeros. Or we'll be given solutions and find the other zeros. So if we are being asked for zeros or for solutions, that means that our answer in the end should say that x equals some number, right? So as opposed to when we factor, our answer has parentheses. So maybe that's a little note that you need to write for yourself here, that when we're factoring, our answer is sets of parentheses. And when we're solving or finding zeros, that we are looking for x's, like values of x's. So just watch out what the instructions are asking, how your answer is going to be different, but we've seen that before. Just make sure you're reading the instructions clearly. But really the whole process, other than that, is essentially the same. So one thing that is different about this problem, I'll have you notice, so they give us a function, and then here they're giving us one of the zeros. So I want you to notice how this information is being given here. It just says x equals 3, or here it says x equals 2. So this is the actual value of k. We are not going to change its sign like we did here. Okay? So this was a factor. We had to pull the k value out. When we pull the k value out, we switch the sign. This is the actual k value. Okay? So if you're given an x equals whatever, do not change the sign. So that's gonna be one of those little things that's like so easy to get kind of mixed up or forget. One time I change the sign, one time I don't. I get that it can be confusing, but here's the rule: if you're given the answer, or the solution, or the zero, do not change the sign. If you're given the factor, change the sign. So be really careful about that. Okay. But other than that, everything stays the same. I look through the polynomial, look for gaps, don't see any. So I'm right 3, since that's the value they're giving me. That's going on the outside of my box. And then 1, -2, -23, and 60 are going to go in my box. Remember, we still need 0 here, so as we do the work, we can kind of check that. So bring down the 1, multiply. It's +1, not -1 like I was about to write. 3, that'd be -20, and -60, and that's good because that's going to give us 0 here. So we got 0, and so we go and, which is kind of like a little check, right? That worked out good. Now we need to go back and put the x's back into the problem just like we were doing before. So we have x cubed. We're taking out an x still, so this is going to be an x squared, an x, and then there's my constant, and then there's my remainder, which is 0. So my new polynomial is x squared plus x minus 20. So we need to factor that and solve that just like we did before. Now we're solving this equation instead of just factoring this expression. So, which again we've done already, so it's not that big of a deal. We just need to factor this left side. You should notice that's going to be AC method, shortcut AC method 2, which is really nice. So we need to think of factors of -20 that add to be 1. Of course, factors of -20 that add to be 1 would be 5 and -4. So since this is shortcut, that means I have x plus 5, I have x minus 4. I'm going to go and stop there. We're still just solving this equation right here. And so we look at that and we say, okay, well, how do we solve that? That's x plus 5 equals 0, and then this is x minus 4 equals 0, but of course that just means that x is -5 and x is +4. So we have 2 solutions here. Now remember, this problem should have 3 solutions that our highest exponent tells us how many answers there are, and right now we only have 2. Well, don't forget about this guy over here. This x equals 3 is the other answer. Oh. So there are the three solutions that we have to this problem. And just like we did before, if we used our graphing calculator, we could have seen those 3 points. Again, we're kind of working towards being able to solve problems. And here we already see a problem that we wouldn't have been able to solve before. But we're going to be working towards solving problems that don't have all the answers that we think they're supposed to have in the way that way that we think they should, which again is a problem that I gave you guys on that last worksheet that we did. There was one of the problems, that number 7 graph was supposed to have 4 answers, but only had 2 that we could see. We're working towards understanding why that's happening. So right now we're doing problems that are very easy and straightforward as far as we can see all their answers nicely. But we're going to work towards the problems where we can't see all the answers nicely. So we have a goal. So I understand that some of these problems may seem kind of easier. Why don't we just use our calculators if we can graph them and do it? Because even the calculator doesn't know how to solve some of those problems. So we got to be able to figure out how to do that on our own. So let's do this last example. I did put a reminder down there at the bottom. Remember, the degree can tell us the possible number of solutions. So here is that, what I would talk about here. Since that said 3, we knew we had to have 3 answers. So just one of those little things to remember. So again, as we look at this problem, it has a highest exponent of 3, so that when we're done, we better have 3 x's as our solutions. We're going to approach this the same way we approached the last one. Check for gaps in what would be the dividend. There's none. Then here's your x value, so don't change the sign. So that 2 is coming straight over. And then I have a 1, negative 5, a negative 12, and a 36. So run through your synthetic really quickly. And then again, just using this as a check. Because they gave us an answer, we better get 0 here. So we did, so it just tells us that we did all that correctly. And that's important because this next step, we're going to be using these numbers to write our new function. So this would be an x squared, since we're taking x cubed and taking an x out. This is going to be our x, and then here would be our constant. So we get x squared minus 3x minus 18. That's equal to 0. We're going to solve that, not just factor it. So one of the nice things about these problems is that I want you guys to be thinking about how we're shrinking the problem. We started off with an x cubed, and we were able to take one of the answers out and give us an x squared, which is more easily factorable. Again, this problem is not factorable in the way that we have it. It's the way it's written right now. So we're finding a way to shrink the problem into something that's smaller, which is more factorable. So it's a really important idea that how the problem is smaller now because we took out one of the answers. And once it's smaller, it's easier to factor. So AC method, shortcut AC method, since A is 1. So we need factors of negative 18 that add to negative 3. And that would be negative 6 and positive 3. So that would give us x minus 6 and x plus 3 equals 0. So x minus 6 equals 0 and x, so that means x equals 6. And here we get x plus 3 equals 0. So that means x equals negative 3. So there's 2 of our 3 answers. And then don't forget about the first answer they gave us, x equals 2. All right. So that's how you do that. That's how you use an answer to find other answers, or it's how you use a factor to find other factors. And eventually we're going to get to the point where we don't have to be given an answer in order to find other answers. We're going to find a way to get that information on our own. But right now we're going to kind of baby step our way there to it. So here we are given one of the answers so we can find the other answers, or given one factor so we can find other factors.